All right.
Next coffee hour. We do have coffee hours monthly, and so our next coffee hour is using generative AI productively for teaching and learning, and that's going to be hosted by our optics community, our two-year college. And last, actually, I have one more thing. Second to last, there is a post coffee hour survey, and I'm going to be dropping the link to that survey in the chat towards the end of the hour. If you are interested in receiving a certificate of attendance for this session, you must fill out that post coffee hour survey. Even if you don't want that certificate of attendance, I really appreciate the feedback. So please take a second. It will take you 30 seconds to fill out that survey. I appreciate it. And then last, just some coffee hour engagement expectations. Coffee hours are supposed to be interactive. We do have a little bit larger group than what we generally have at a coffee hour, so our interactions might be a little bit different tonight. But we do want you guys as the audience to participate actively. When invited, please share ideas, ask questions, and listen with curiosity. Share the space. There are a lot of us in this space, so please be mindful of sharing that time. Be respectful and supportive to your colleagues and to our presenters. Stay present. This is going to be a fun night, and I'm really excited to see what happens next. So that's all from me. So I am very excited to hand it off to Paul Hewitt and his nephew John.
For that, thank you so much, Justine. My role here is to be a moderator. We can't all have unmute at the same time. That would be bizarre. But through the chat, if you can put your comments and questions for Paul, I can read them to him and he can respond to them directly. Paul, welcome so much. This is a man who needs no introduction into the world of physics education. Paul Hewitt, author of Conceptual Physics, and I have a special treat for everyone here tonight, aside from sharing my uncle, is look what I have here.
This a new edition.
This is the very first edition of Conceptual Physics published in 1971. It's been through umpteenth editions since then, and the man responsible for that is with us today. Ladies and gentlemen, without further ado, Professor Paul Hewitt.
Hi, everybody. I'm talking to the happiest people in the world, I think. And why would you be happy? Because you're not teaching keyboarding and you're not teaching accounting. You're teaching the rules of nature, a very, very relevant course for all. And we call that physics. And you talk about AAPT, that's where all my friends come from. And the best friend I have in the world is from AAPT, and he's with us tonight. That's Ken Ford. That's the kind of friends you meet when you're in AAPT. But here we are teaching the best of all courses and having a good time. Any questions you have, I'd like to talk about it because I don't have any script.
Okay, well, I've used your figuring physics questions in 3 or 4 of my different courses, in physics, in astronomy, and in energy for the future.
Nuclear fusion?
No, energy for the future.
Oh. Energy for the future.
Oh. Yeah. What future?
That's good.
Yeah.
They're all general education courses.
Yeah, well, I think you've got a pretty good rap there.
Yeah.
All 3. Yeah.
I want to say hi to Ken Ford, too.
Oh. He's the man.
Ken, remember me?
He's the man. Yeah. He makes me feel young. Yeah.
Because I'm teaching at UMass Boston.
Boston. Oh,
UMass Boston.
Yeah, well, I went to Lowell Tech.
Yep.
Used to be Lowell Textile School.
Right.
And then I went up to Lowell Technological Institute, and it was fast and furious, information overload, and I did a very, very bad job. And I did all the things that were wrong as a student. But what I did find there was I knew what I wanted to do when I became a student. I mean, when I became a teacher, not to make all the mistakes they made.
Were you in the physics department?
Yes, I was a physics major. No, I was a student.
Oh, Marty Wilner?
Whoops.
Wally who? Yeah.
Marty Wilner.
No, I don't. Doesn't ring a bell.
He was in the physics department.
Yeah. Well, I was in the physics department before you were born. It was 1958. So you weren't even
He was
here.
20 years old in 1958.
Well, I didn't start school till I was 28. And everyone else was 20, 18 or 19. So I was the old man of the group. And I find I'm still the old man on this session right now. It's nice to be the old man.
Paul, we have a question from Chris Louis,
All right.
who asked, what inspired you to write Conceptual Physics?
I wrote Conceptual Physics for one reason only, to augment the notes for my class at City College. And that story is, it's in my memoir, but it's a story that's unique. I didn't write this for any professionals, and I didn't think it would ever be published. It was merely notes from my class, and it was in the summer of '69 when the moon landing occurred. I wrote a bunch of notes only for my class, but I had so many students, 1,000, that there were 1,000 books in the bookstore. And when reps came by and saw those books, they said, this might be a good book to publish. But I instructed them, no, this is a City College book because this is a Physics 10 book for my own class. And I don't have any problems. I'm just talking about the ideas. They'll have problems later on if they continue with physics. I just wanted to give them the ideas of physics and to see physics how I saw it. It was my way of seeing the world, and I just wanted to share that with them. So they were just notes. And that course history will now show that the publishers thought otherwise, and before I know, I was published.
Did you get any inspiration from Eric Mazur?
Later on, Eric and I were doing the same thing at the same time. It was, I called it check your neighbor, because I think that in teaching, we can get up there and talk to ourselves for a whole hour. It's not going to do much good. What I felt that as a teacher, we're like a conductor in music. And we're pulling questions and pulling activity from the students by asking questions. Well, Eric did the same thing, and he called it convince your neighbor.
Yes.
And I called it check your neighbor at about the same time. He was wonderful. He taught at Harvard.
It was peer instruction.
Oh, that was wonderful, the peer instruction. When I taught my Physics 2A class, I used all his slides. They were great. Cheers for Eric Mazur.
Next question from Rudra. What is your advice to students of today who have a low tendency to read textbooks?
I can't, bear in mind, I'm a relic. I'm a 20th century person. And I taught at a time when there was no smartphones and it's a completely different world. As to what's going on today, I stand back and look and hope.
Well, there's a related question asking about your Hewitt-Druitt videos. There's been some trouble, I know from behind the scenes with Marshall's YouTube channel for his Hewitt-Druitt videos. For those students who aren't going to read, you can go to conceptualphysics.com and you'll find links to all his videos.
Yeah, those were a happy accident, and that sort of defined me, really. But there's 36 videos, 36 lessons, and they're all there. YouTube, Conceptual Academy.
Yeah. Paul, how did the physics at Utah State University impact your experience in physics? Can you talk about your time at Utah State University?
Oh, Utah State University. I have nothing but cheers for Utah State University. That's where everything came together. And I was fortunate to become a recitation instructor. And we were using Haladan-Resnick, and my task was to explain all the Haladan-Resnick problems. And that's when it all came together for me. And I found I could explain this to the kids. And that's when I realized I really, really got to be a teacher. But Utah did it for me. I had 2 years there and 2 wonderful years. And I also had the very best instructors I've ever had at Utah State University. There's John Merrill and Farrell Edwards. They were wonderful. They did it for me.
Another question from Trevor asking about students are learning physics at earlier and earlier ages, but at earlier ages, they don't have the math background. Your suggestions for reaching students at
earlier? I have something to say about that. In my own schooling, there wasn't 1 year that we didn't have mathematics. Guess how many years we all had for physics in high school? Began with a Z. I think there was a physics course, but it was not attended. No, physics wasn't popular. Physics was in the background. Popular in the rest of the world, yes, but not in the United States. That's the way it was.
Joe asks about a book you wrote with Lewis Carroll Epstein back in the late 1980s.
Yeah.
What can you tell us about him in your collaboration?
Well, things didn't work out personally, so I just stepped aside and told Lou to go ahead and do it on his own. So that's just a little footnote in history.
Would you describe, this is from Dean. Hey, Dean, our lab co-author. This is from Dean Baird. Tell us about your work promoting conceptual physics in the early 1970s. Was conceptual physics immediately received warmly?
It turns out it was. And the reason it was the timing. I couldn't have had better luck. The friends that have written other books are equally good, if not better than mine. But mine had the subtitle, a new introduction to your environment. And at that time, students were clamoring for courses that were relevant, that weren't just, hodgepodges of things to get through to satisfy requirements. But I made the courses as delightful as I could. The delightful views of nature, and it took off. And it took off very surprisingly. I didn't expect it to do that. And then I thought, when the second edition comes out, I'll be in the background because the professionals will come along and see what I do, express everything, not cover physics, explain physics. And the rest is history.
Can you describe how your cartoons came into play?
I'm a cartoonist. I look at myself as a cartoonist. And when I was in high school, I did the cartoons for the paper. And to which the counselor told me that I wouldn't have to take those academic courses like physics and mathematics because I'm going to be a cartoonist when I get out of school. So I took his advice and I took no physics, no nothing. And when I decided I wanted to go into physics at the age of 25, I had to go to Newman Prep in Boston and take those courses that I missed in high school. And at Newman Prep, I had excellent, excellent teachers, all of them. And I learned a lot at Newman Prep, getting ready for Lowell Tech.
This is a question from Bill. He says he hears that you have a bio memoir coming out in June. Can you provide any background about your biography?
Well, I have a memoir. And
memoir.
Yeah, I could show it here. It's described here, but it's called "The Awesome Life of a Physics Teacher" by World Scientific in Singapore, and it's just about out now.
So if people wanted to get hold of that, they would go to World Scientific and type in Hewitt?
Yeah. Or they go to what is it? Amazon.com. Barnes and Noble.
World Scientific.
Yeah, the comment is it's not quite available there yet. So if folks, I'm putting the name of the publisher as World Scientific in the chat.
Yeah.
If I can find a direct link that I'll put into the chat as well.
Okay.
Whatever.
Lil is pointing out to me that at the bottom of this little flyer, it says, quote Hewitt, and you'll get 20% off. let me say this. I would advise you not to get the book at all until it gets in paperback because it's too expensive now. I don't even have a copy. I had one copy and I gave it to the fellow upstairs. Otherwise, I'd show you on the screen there.
So I've been using OpenStax for my books, and they're free.
Yeah, I know. I instead of doing the textbooks free with Pearson, of course they're not selling anymore. They're just no one's buying books. But I have my videos free, so I'm trying to be generous too. My videos and all my ancillaries all free.
Yeah.
I got a website, conceptualphysics.com, edited by John Zahaki, my nephew, and you can find samples of figuring physics on that website. And that's my present passion, making those available to more people.
Yeah, I think what we'll do is for the memoir, we'll make it available through conceptualphysics.com, and that's the easiest way to do it.
Sure, yeah.
Yeah. We have a question, Paul, about ninth grade teaching biology versus teaching physics.
Yeah.
You have a word to say about that?
Yeah, I can say this. There's 3 courses. There's physics, chemistry, and biology. Those are the major science courses. Which of those is the simplest? Well, come on. Which of those has the least number of terms at the end of a chapter?
Physics.
Which of those is the direct rules of nature that's fundamental to every other science? Which of those? 3. I'm not going to tell you. I'll just let you guess.
Physics.
But
Yeah,
we have
he's
now,
typing in physics.
I'm glad that people like Fred Myers did a nice thing, put physics first. So physics should, I think, like the rest of the world, come before chemistry, and then that be followed by the most difficult and the most intrusive. That's biology. It's so difficult. We're still trying to find out. Boy, there's more we don't know in biology than any other course. So physics first, chemistry next, then biology. That seems to me the correct sequence.
We have a question from David Chrismond about what topics in physics are most challenging to create cartoons of.
The most challenging? I try to avoid those in conceptual physics. I don't want to challenge the students at all. I'm sorry.
No, for you to draw.
Oh, that's just a gift that I had since childhood. I used to draw comic strips, but I don't have difficulty drawing cartoons. So I don't know which is more difficult. I don't know. What I cannot do is I cannot draw caricatures of a person's face that fit the face. I don't have that talent. My cartoons are as basic as they can be, the fewest strokes, and I never thought they were a big deal, really. But it's nice to be an author that does his own cartoons, a lot of them in the figures, because that's where mistakes are made. So being a cartoonist and sign painter came in handy when it came time to write and illustrate my own book.
Can you talk briefly about your cartoon workshops that you once held and the value of drawing in the classroom for students?
Yeah.
Indeed, not for accuracy.
Yeah. That's one of the sessions that was the best attended and the one I had most enjoyment in AAPT meetings was scheduling a cartoon workshop, which meant finding a place with a lot of chalkboards. Remember chalkboards? They went through a whole series of things. And I'd get a whole bunch of people, maybe 25 people attending the shop, and they'd all get up at the board and copy my drawings. And the punchline was this: I'm the one that's the cartoon expert. Now, look at my drawings compared to the rest, and there's several that are better than mine. The difference between me and other people is I just do them quickly and I don't give it much thought. But if other people could do it a little quickly, they'll do every bit as good as I do. So I'm trying to encourage people to do that, because any physics teacher comes into class and does something a little artistic or a little music. You know, you yourself, John, you chemistry professor, when you come in with your guitar, you're a different person, you know. But you don't have to do that when you draw little cartoons on the board. And if they're not fast, you're showing off, and you don't want to do that. But you do them quickly, and if you do that, it shows the students you've taken the effort to make your lectures and presentations more nicer, more interesting. I hardly recommend doing it. And I wish I could do those workshops again, because that's a nice thing that seems to be missing in a lot of classrooms.
Can you talk a bit about your practice pages, your practice page worksheet?
My practice pages, well, I think that's my best work, really, is the students want to take the physics and apply it to real world situations. And the practice book, I think, is free, but it's always been an ancillary to the high school versions of conceptual physics. I hardly suggest that people use them, but that's tearing out paper or making copies and have the students at their desks writing with pencils. And maybe pencils will become obsolete. Maybe we won't know what they are in the future. Even the wires that we see in our machines today. My friend Ken Ford says, a little nice cartoon, he says, have a little kid saying to his father, "Daddy, what's a wire?" Because one day they won't know what they are. And so the practicing physics, I think they may be 20th century obsolete now, but it's where the students do connect the physics with answering questions and making diagrams. I can't overestimate the value of vector diagrams, getting the vectors right. It's such a joy to teach physics. There's so much about it that's just lovely.
Paul, were there chapters or concepts that you enjoyed teaching more so than others?
Yes, yeah. Mostly mechanics, and I would talk about things that related to their everyday worlds. And so it would be mechanics. I particularly enjoyed satellite motion. And, when I went to school, satellite motion was stated as this: if a projectile high and above Earth had enough velocity that the centripetal force, they call it centrifugal reaction, equals the gravitational force, there you have orbit. Okay, now try that to some kids. Some kids want to know, how come a satellite doesn't fall down? Well, that's because the centrifugal force equals the gravitational force. Oh, okay, thank you. Now I learned
something. It does fall down.
You learn nothing.
Satellite does fall down.
They do. They're falling all the time. And that's the point.
But it's also moving horizontally.
Well, if they're not, they're going to fall and hit the Earth. But when they move horizontally, they make a little curve, don't they?
Right.
If that curve matches the Earth, the curve of the Earth,
right,
it's going to keep missing. They go around and around and around and never hit the horizon.
That's Newton's famous diagram from the cannonball off a mountain.
I don't talk about centrifugal force, gravitational force, not in that context. This is so easy. But talk to any people in the street and they don't know. I'm telling you, I went to a conference a little while ago. I talked to a lot of students, and I talked to a lot of students at a Sigma Pi Sigma meeting that didn't correctly answer, are these satellites above the Earth's atmosphere, above gravity, both or neither? And it was disappointing. And what it meant to me is we pay a lot of attention to advanced physics and almost none to elementary physics. If some people ask me, what kind of physics do you like, Hewitt? I like about 9th or 10th or 11th grade elementary physics, because I keep learning more all the time.
Now might be a good time, Paul, to show the cartoons that you have for class demonstrations you wanted to share with people. Your PowerPoint slide?
Oh, yeah, I have some of those. Yeah. Let's see if I can.
You want to click share screen?
Yeah. Yeah. Oh, any way to show those?
Here we go. You're good.
Yeah. Well,
What?
yeah. Okay.
Okay, it's showing now.
Okay, which one?
Guess who doesn't have practice with PowerPoint and Zoom sessions? That's right, old PGH. Well, here's one here. We all do the paper drop. But instead, I learned when I was 90 years old, and I'm 94 now. I said, hey, what would be better than dropping a little piece of tissue paper on a book, dropping it, to draw a feather. And let me ask you people, if I drop these both, which would accelerate to the table greater, the book or the feather? If you have a neighbor, check your neighbor right now and ask which would have the greater acceleration once released. But you know what? I'm not going to tell you what the answer is, and I never would in school either. If I was a beginning teacher, I would give you the answer and drop it and show it, and to show how smart I am. But I don't do that. What I do is I say, I'll do this next week, and maybe it'll be on a quiz. So you people have a chance of finding out what would happen. You can go to the your computer and see if you can find it, or you could just do it. Do it? Yeah, do it in your own home, and then talk about it with your family. This is a fantastic one. This is a fantastic one. What it's doing, it's doing every bit as much as, let me show you. Right here. We're all familiar with this. The coin and the feather dropping, both at G, if there's no air drag. Well, guess what that book does when you go back and put it in the book? That does the same thing. So that's one I like. Like I say, I used to do this and I didn't get the feather till later. I also like this for a topic. Our pinhole camera, and apply that to pointing to the sun. And what are you going to see? You're going to see some images of the sun. You're going to see this. And this is in chapter 1 of all my books. And what it is, it's kind of nice. If you know the distance to the sun and you don't know the diameter, you can find it in your backyard or even your front yard on a sunny day. That pinhole image, the image on the ground is an image of the sun. And the ratio of the diameter of the little hole to the height above to the paper is the same ratio as the diameter of the sun to 150 million kilometers. So I like sometimes in class, I say, hey, I got an assignment for you. This one's going to be measuring stuff. You guys find a ruler or a tape measure or something and go out on a sunny day and measure the diameter of the sun. I'll tell you it's 93 million miles away, but I'm not going to tell you what the diameter is. I want you to measure it with that ruler or that measuring tape. Go for it. And of course, they're stunned. How can they possibly do that? Well, when you show them, timing's important. They will appreciate this little diagram. It's wonderful. I can't imagine teaching a class and not including this one here. I can't imagine it. It's just too delicious, and mostly the sunballs that come out. Where we go here. This is across the street from me. These are images of the sun cast through little openings in the trees above. And look, there's mostly circular shapes. Now, at the time of an eclipse, a partial eclipse, I'll show you, we didn't get there. There's Dean Beard showing it. See the little, how the images turn to crescents. Well, let's go on. We talk about Newton's second law. Here's a beauty. I like this. This is a relative of mine. This is a question we all miss. What at the tippity top of an object thrown upward, what would be the acceleration at the very, very top? And I think everyone that's watching this, I think you will say that when you first heard this, when you first encountered this, you got it wrong. I certainly did. I got it wrong. And I even wonder if Ken Ford, when this question was posed to you, did you get it right the first time? Ken Ford is a genius. He may have, I don't know. My guess is that, no, not at first. They confused it with velocity. And so, the velocity is 0 at the top. We didn't ask for velocity. We asked for acceleration. And by the way, what this slide shows is when you're asked a question with something like acceleration, let the equations guide your thinking. Don't shoot from the hip. Put the equation down and fill it out. My goodness, look at this. It's G. It's G when the velocity equals 0 and there's no air drag. Yum, yum? You bet. So this is the kind of thing we do when we're teaching. And so I'll get off now and get back to the questions.
Great.
There's Ken Ford right there.
You muted me again.
I'm unmuted you.
Hello, Ken.
Say hi.
Hello.
Yes, Ken.
You're on.
Oh, am I on? I'm
You're on.
sorry.
You're on.
I didn't know whether you said yes, hello, or whether you had a question.
Oh, the question was, what's the acceleration at the top of the path of a projectile thrown vertically upward?
Well, it's 0, of course.
Yes, everyone knows that. And that's why we take physics courses, because we find out that what we know is not quite there yet.
Well, I
Good to
got
see
the
you,
mic
Ken.
for a moment. Let me just remark that my time with Paul Hewitt goes back about 50 years. I used CP1, Conceptual Physics, first edition, in a
Wow.
course at UMass Boston, and he and I have been scuffling ever since.
Well, Ken, I got to say something about you. When Mario Iona was trying to push me down into the mud because I wasn't respecting the mathematical structure of physics, of course I was, but I made a distinction between that and computations. And you came to my rescue because he was finding all these little mistakes. Ken, you came to my rescue and you helped me in all these additions. So if my books are accurate here and there, it's because of you. And I want everyone to know that. Your book, Basic Physics, that was one of the books that I plagiarized a little bit when I wrote mine. And when you found out that you were okay with it, and you got on with me, and you've been helping me ever since. You were wonderful. I love you. You know that. And Lillian does too. I think Diane does too. Everybody loves Ken Ford.
Diane, Diane
That's
is
right.
my high school teaching friend from more late in life. After I stopped teaching at universities, I taught at Germantown Academy, a local high school, and she was my colleague and handholder.
So I still get to teach from your book, Paul. So don't worry. A couple of us are still actually using the it's a used version. I'll give it that, but
You're my kind of person, Diane.
it's great.
Yeah. It's good to see you, Julia. What a surprise.
Yeah, well, you gotta.
Yeah.
It's your words of wisdom about teaching resonate. Just how to reach the kids. I mean, And when someone was talking about ninth grade physics, teaching it early, I will say one thing. I didn't teach it before that. I worked in engineering. I went to teaching a little bit late, and then I've only taught physics in the ninth grade. Later, I taught like an AP course to the seniors, but as ninth graders, I think you have to explain so much more. And so you really have to lean into the demonstrations and lean into the physics as opposed to, really kind of hiding behind the math a little bit. So it's
Yeah.
if you haven't done it, it's worth the exercise, just teaching at that level where there's just algebra at your fingertips.
I feel so elated that you still feel that way because it's been many, many years when Ken was teaching, Ken, icon there. What's he do is he teaches kids, and then you were doing tutorials for kids. Ken, this is wonderful. You were the passionate teacher trying to get this into the kids, and I joined you, and Diane too.
It's fun.
I'll say my wife Lillian, who's sitting right here, she's yum yum. And then my nephew Johnny has always been polishing too. Anyway, what a wonderful career to be teaching the world, the rules of nature, and what we call physics. And it's relevant with a capital R. Yum yum.
Oh, we have a question from Dwayne Merrill wondering,
Dwayne Merrill, my friend Dwayne Merrill from Utah.
there you go.
Dwayne, what's your question?
How to convince, what's the best way to convince others that physics first in high school is the way to go?
Well, it was an uphill climb, and I don't think it's there yet. I don't think it's there yet. A lot of it has to do with turf. There are more biology teachers in a high school than there are physics teachers. In fact, in some high schools, there's no physics teachers. They'll have the math do a little bit. But it's a question of turf, how you can get people to stop. I remember one time I went to a meeting of teachers, and I said, what do you guys think about someone like me coming here and telling you, I know you like your little classy rooms with a small number of students, all with nice clean fingernails. How would you like it if I come by and says, no, I think you should give that up and come down and teach the masses, dirty fingernails and all. What do you think about? They didn't like it at all. So it was a very hard thing to get people to teach at physics first. I talk a lot about that in my memoir.
Can you talk about your old San Francisco videos and compare them to your Hawaii videos? Do you prefer one over the other?
I think in the old ones, they're called Conceptual Physics, Conceptual San Francisco years. I was more animated there, and I had a class that was more jazzed up. I had more class participation. When I went to teach in Hawaii, I made a drastic mistake. I was in a small studio, and the students had the option of seeing the video outside rather than the classroom. And above my lecture table was a camera that would roll back and forth. All I had to do was to cover that camera with a towel, and I would have had more participation, but I didn't. The kids were frightened by the camera on them. And therefore, I had one of the least classes that I could talk with in my career. But my upside of that is, that's good though, because if people say, Hewitt, the author of this book, my students are more inquisitive than his were, then that will be serving my purpose. I don't have to be the best. I just have to get other people to be the best. So much on that.
Can you talk about the merits of starting a physics course with kinematics versus force?
Yeah, there's only one thing wrong with kinematics. Well, I'll tell you the thing that's wonderful with kinematics. It's fun. The green car can get to the sidewalk before the red car, given these particular kids. Of course, some kid says, well, who cares? Well, that's another story. But kinematics is, my complaint with kinematics is that it just absorbs too much time. My grandson took a course in physics when he was in Hawaii, and he took my book, and I said, well, this is wonderful. And the teacher spent all the time on the second chapter the whole semester. He didn't want to take any more physics. It gets overtime because it's fun for teachers. And I want to get up to rainbows. I want to get up to relativity. I want to get up to nuclear physics. I want to get up to a broad, let's look at the whole elephant before we start measuring the tail. And so I want to get an overview of everything. And kinematics seem to take up too much time. That's simple.
Mm. Back to your Hawaii videos. We have a question asking about that blonde male student who you'll recall is Lee. Remember?
Oh, yeah.
Lee?
Yes.
Yeah,
Yes.
they most appreciated, I imagine. The question is, do you know what's happened with Lee?
Yeah, well, not much, but Lee was a music major and he's a pianist. And he actually wrote songs, piano tunes. And I was so glad he was there. And he was the one that was not intimidated by the camera. But that was Lee, oh my God, what was his last name? Zimmerman? I can't remember.
Yeah.
Lee was wonderful. And he sort of like was the hero of the student body. He went on to do more music, and I think he had a good life. Of course he did. He had a grounding of conceptual physics.
Question about math. There's a misconception that conceptual means there's no math. Can you talk about your treatment of math within your conceptual approach?
Yes, yes. I got a friend, Howie Brand, at a high school. I went to visit him. He was at Suitland High School in near Washington, D.C. I went to his storeroom, and there's two signs. And one was a sign that an arrow, it says physics this way. And the other was another arrow, and it says conceptual physics this way. No, he said, no, it was real physics. One sign said real physics, the other said conceptual physics. So conceptual means it's not really physics then. And so that's always been, the downside for at least the reputation of the book. But what was the question again?
About using math.
Oh, yeah. I like to say this in one sentence: comprehension before computation. And conceptual physics is all about comprehension. Where's the computation? In the next course that people take, if they take a next course, and they might not. And it's okay if they don't, because I always felt that people like Feynman and Ken Ford didn't need to take an exciting physics course to get in there and fill our land with physicists. They're there, they will come. And I'm dealing with the average people who I want to read Scientific American and maybe take science a little more seriously than many. At that time, there was a big anti-science time. And I want people to be on the right side of science.
We have a comment from an old friend of yours, Janie Head from Texas.
Oh, Janie, yeah.
Yeah, she
Janie, you're still with us.
Yeah. She says hello and thank you for all the physics you've helped her out with. And she says she's retired now. She doesn't miss all the grading, but she certainly enjoyed her careers.
Yeah.
And
well,
yeah. Just asks how you doing. She just asks how you doing.
I'm doing fine. I'm old and I'm wearing out, but no more than any machine. I don't have any illnesses or anything, and I'm just blessed, really, that I don't have any medical problems other than borderline diabetic, and but just simply wearing down like any machine does. But otherwise, I'm doing fine.
But your time is spent mostly, I guess you were working on the memoir, but can you talk a bit about the figuring physics efforts you've been doing for the APT?
Yeah. But I'm trying to push the idea that posting little figuring physics pieces and glass cases outside of classrooms. Now, that's 20th century talking. Someone else could translate that. Of course, maybe no one puts anything in glass cases anymore. But it'd be a question with an insightful answer. And instead of showing the answer right away, I use a wait time, usually of a week. And the answer will be shown the next week. I'll have 3 questions posted, and students will have to wait for a week before they see what I consider the answers. And it's what it does is it fosters discussions out of the classroom. And I can't see any downside except the bother that a teacher would have to do them and forget to, don't forget to put the answers up at the same time. But I'm trying to push that idea, and that's my major thrust right now, is getting people to use figuring physics. They could do it electronically too. Now, here's the big thing. Here's what I learned from AAPT. An APT editor, oh my God, who was it? It was, oh gosh, I can't remember the name. Do you guys find that you forget things a little more often now than before? Well, it's part of falling apart. But anyway, they said, we're not going to put the answer in until next month. How's that? I says, oh, that's wonderful, wonderful. So there's a wait time of 1 month. And that gives people 1 month to ponder the question. So I highly recommend that people do this. And they're all free. Johnny's posted them already on the conceptualphysics.com. But print them out or put them in your email, your electronic, but pose the question and let the answer come at a sufficient wait time. That's my present passion is making those, and I love doing those for the physics teacher.
Here's a interesting question from Sarah Scupian regarding quality versus quantity. Your books will have a lot of topics in them, and that I understand is to provide the instructor variety. But in terms of fulfilling a requirement of a physics program, can you talk about spending more time just to turn the student on versus covering a lot? For example, spending a lot, the whole semester just on Newton's laws.
Yeah. All right, Johnny, hold up copy of that book that you just held up. All right, now I'm gonna hold mine up. You want me? Can you see me? Do I have to click on there?
That's it.
My little. Oh.
What?
Can you see me?
Yes.
Okay. See how thick it is? How big it is? You know why it's so like that? Because I was told that this might be the last book in print. And this one here is only for rental copies. Okay. It's thick. It's got everything in there. Everything I wanted to say is here. Before, I made it cut down, not so heavy. But I think I have the okay to do that, because if it's electronic, people can skip through the parts that they don't want without feeling that it's a great big book and they've only had some of it.
So what do you recommend for a teacher who needs to select from that list of topics on what to teach? Should they just pick what they have fun teaching?
Yeah, well,
things...
if you have the freedom to teach what you want, and that would the best be, of course, a community college, then teach the stuff that you're best equipped to explain, or teach the material that you enjoy. And I don't want to teach anything that I don't enjoy. I want to teach the goodies. And where's the goodies? Physics has more goodies than any other discipline. You know, some people say, how can I make my physics course interesting? Make it interesting. It is interesting. It's physics. It's the rules of nature, and all spelled out with nice little cute little equations. So teach what you feel best at, and leave the rest to someone else, because the kids are going to forget everything you've done anyway. And what's going to be left at the end of your course is just the flavor. The flavor. They're going to forget all the facts and all the diagrams and all the little equations and all the little cute things. And they'll be left with whether they enjoyed the course. Oh, I say, I hated that course. It was too much. It was information coming in faster than I could process it. Let that not be you. There's enough courses do that. Let your course be the delightful course, the course that they like, the course that they talk to their friends with when they go home, that kind of thing. I mean, there's one little slide I should have showed. It's person jumping up. We talk about, y equals 1/2 gt squared, and we use that in our kinematics. I like a show of hands, but I can't see you all guys. But how many of you people do not teach hang time? The fact that the longest you can stay in the air for a standing jump is 1 second. And most of your students can't do it more than a half a second. Hang time is a delicious topic. It's one that says, oh my God, I didn't realize that. You mean Michael Jordan, when he jumped up, he couldn't stay in the air for 1 second? Almost 1 second. And maybe the record has been broken. But what you do is y is 1/2 gt squared. Put in a half a second and see how high you drop. It's about 4 feet. You convert that to meters, and you got it. That should be taught. And drop a ruler between the big fingers of a kid's hand and see where he catches and measure reaction time. There's all these things you can do that are personal to physics to the people themselves. Holding your hands up and showing, Frank Oppenheimer showed me this one, was hold your hands up like this and look and you see, oh, wow, one hand's bigger than the other. Is the closer one bigger? Yes. How much bigger? Twice? Yeah, maybe twice. Wrong, think ahead. It's 4 times as big. And go ahead and get it at. Do things that involve the people's body themselves. There's enough physics there.
We had a teacher in the comments before talk about how they love to begin their physics course with relativity, simply because they love teaching relativity.
Well, when I taught relativity, and I did most of the time, I had standing room only because I told the students I'm going to talk about a very, very fascinating topic next time. And they would come standing room only. Relativity is a grabber. But it's when I took relativity in college, it was always rotating coordinate systems. They missed the flavor of the whole thing. But I love teaching relativity, and it's in my instructor's manuals, the steps I take in doing it. It can be done. It's heavy. It's the heaviest part of the course, and you do have trigonometry, the right triangle, partners, 2 sides, and CT and C. But it's delicious. And it's really, really relevant, and the students love it. So I can't criticize that if it was a way to get kids revved up.
But then there's the question of state standards. I understand that relativity is not in the state standards, and many high school teachers, their hands are
I think the state standards are written by corporations that want to sell particular books. And so I know, yeah, whatever. Enough of that one.
So your point is that teachers should have the freedom to teach. The idea is not to impart information onto the students. The idea is to impart inspiration upon the students. However that happens.
Delight the students. If your first course is delightful, the rigor of the second course will be welcomed and understood. Let's have the first course at least, and that's what I do. The first course ought to be delightful. The kids should go home and talk with their folks about what you talked about today. And you can keep it all interesting. And yum, yum.
It's about time to wrap up. I just want to say that Paul is exceedingly good at emails. I'm not going to pass out his email address, but if you wanted to talk about how people can reach you, Uncle Paul?
Yeah, I'm not going to give my email. If I did, I'd say pghewitt@aol.com. But if you don't have your your pencil ready, how could you remember pghewitt@aol.com? And I will answer your mail. I like to do that. I miss the classroom. I miss talking with people. I miss talking with students mostly. And here's a chance to talk with teachers. I love that. So I'm available.
Thank you. That pretty much wraps it up. Thank you, Paul, for your good energy as always. And thank you all.
Can I see some of these people? Can I see some of these people?
There's a button you can click up on the top. Maybe we'll do that for you. It's a
My Lillian will do that.
You see it?
Yeah.
See it?
Okay. It'd be nice if I could see everyone at one time. Gee, I wish you guys were. I wish you were in a big auditorium. It would be nice. Yeah. Okay.
Trevor.
Well, anyway, I think I hogged most of the space. I wasn't sure that was going to happen, but I'll welcome that because I'm like most of you, talk. All he wants to do is talk about physics. All he wants to do is talk. Darn right I do, because I love it. And I want other people to love it too. That's a little selfish thing. Maybe I got a little more of a preacher than a teacher, but I want people to love looking at the world through the lens of physics, and never mind all this hogwash and stuff. Come on. It's so interesting and fascinating and together. And it's got little Ken Ford, a little Richard Feynman, a little John Sahaki, and all the other people who love physics. Yum, yum.
Well, thank you so much, Paul. It was great to have you. For those of you participants, you may have noticed I put the coffee hour survey link in the chat a few times. Again, I really appreciate that feedback. And if you are interested in a certificate of attendance, you do need to fill out that survey. But apart from that, thank you all for being here. Thanks for participating and asking questions. Thanks, John, for facilitating. It was a great evening.
Great. Thank you all.
Thank you all. Thank you all.